Okay, if we want to divide with complex numbers, we need to remember that the division process is nothing new. If I look at this first problem right here that says 2 minus 4i divided by 3i, I'd want to notice my coefficients. Those would be my numbers in front of my variables, such as 2, 4, and 3. And I'd want to think if there was anything in common between those numbers, any common factors that would divide. There's nothing in common. So the division process here isn't so much the division, it's simplifying the fraction. The simplification of the fraction is that I cannot be in the denominator. If we remember correctly, back to our definitions of I is equal to the square root of -1, and we never want to have a square root in the bottom of a denominator, in the bottom of a fraction, in the denominator. We always want to rationalize that. So my process here is to try to get I out of the bottom. I can think back to my powers of I. Since this is just an imaginary term in the denominator and not a complex number, then I could multiply by just I, because by multiplying the denominator by I, that is going to leave me with 3i squared in the denominator, which we know the value of I squared is -1, which would leave me with 3 times -1 in the denominator, which is -3. So by multiplying by I have rationalized my denominator. Now I've got to keep my fraction equivalent. So if I multiply by I in the denominator, I need to do the same thing to the numerator. Since there's a complex number in the numerator, I need to distribute that I to both terms. So this will become 2i minus 4i squared on the top in my numerator. If I replace I squared with -1, that becomes -4 times -1, which is +4, and 2i plus 4. So I'd have my imaginary term there. I want to keep my answers, my simplification answers, looking like standard form. So I don't want to say 2i plus 4. I want to reverse that and say 4 plus 2i, being very careful to keep the signs in front of the same numbers. 4 was positive in my previous answer, and it's still positive in this answer. To maintain my a plus bi form, my standard form, I'm going to split this numerator apart and put -3 underneath each of them. So that's the definition of a fraction. So I can say 4 plus 4 thirds, 4 over -3, plus 2i over -3. And then I can even go further when that negative's in the denominator and just say that my entire fraction is negative, to say -4 thirds. And then it's a little simpler answer, instead of saying plus negative, for me just to go ahead and write that as minus 2i over 3, or I could pronounce that as 2/3 I. And I can see that my answer looks like a plus or minus bi now. So when I'm given one like number 2 with a complex number in the denominator, I want to be a little more conscientious about what I do. I can't just multiply by I here and get rid of the denominator, because that's a complex number. If I were to multiply by that denominator by I, all that's going to do is move 2 to be an imaginary term and I to be my real term, because that'll become I squared. So I've got to remember what we learned about when we were doing our multiplication, that I can multiply by a conjugate and it will always result in a real number. So the conjugate of 2 minus I is 2 plus I. And if I do that on the denominator, I must do the same product on the numerator. So this division problem has just become 2 multiplication problems. So it might help me here to put that numerator in parentheses and remind me that I want to distribute the complex numbers. So that'll become 8 if I multiply everything in the second by 4, plus 4i. And if I distribute my 3i, that becomes 6i. plus 3i squared. I'll just go ahead and simplify my numerator all the way before I work on my denominator. I squared is going to become -1. And I can combine these two like terms. So that will leave me with 8 plus 10i minus 3. Combine my like terms a little bit further, and I'm left with 5 plus 10i. Okay. In my denominator, I'm going to distribute 2 minus I times 2 plus I. I recognize in the beginning these are conjugates, so I'm expecting my imaginary parts to cross out or cancel each other out, be opposite operations. So I'll distribute by 2, and that becomes 4 plus 2i. And then -I times 2 is minus 2i. And then minus I squared. Go ahead and combine my like terms here. This I squared becomes -1. That was a negative I squared. I want you to be real careful with your negatives. So what that's really saying right there is minus -1. So that will become 4. 4 will stay in the front, and you'd have a +1 on the end. Notice what happens here in the middle, just like I expected. 2i minus 2i leaves me with just a denominator of 5. And if I go ahead and put both of these terms over 5, then I'm beginning to resemble my standard form. When I do that, these fractions will actually reduce, so I certainly want to do so. 5 over 5 will reduce to be 1, and 10i over 5 will reduce to be 2i. So that reduced quite nicely. Let's do one more together. And this one has a complex number in the denominator, so I'm going to need to multiply by 3 minus I, which is the conjugate of that denominator. If I do it to the denominator, I must do it to the numerator. My numerator has one imaginary term, so it's not quite so difficult with my multiplication. I'll distribute 6i times 3. That'll make 18i. And 6i times -I makes -6i squared. I'll go ahead and clean that up. I squared becomes -1. That's a -6. So that's going to become a +6. I'm going to go ahead and move that to the front because that's a real number. And then 18i remains positive when I rewrite and rearrange. In the denominator, we'll distribute 3. That becomes 9 minus 3i. Remember, these are conjugates. So we're going to hope that those middle terms cancel out. We expect that to happen. Plus 3i minus I squared. And just like I predicted, those middlemen will cross out. I squared is -1. So once again, I've got minus -1, which becomes 10. 9 plus 1. And both of these fractions can reduce, which I need to do so. 6 over 10 will reduce to be 3/5. 18 over 10, let's see, I can divide both of those by 2, correct? So that'll leave me with 9/5 I, or 9i over 5. That I could go in the numerator out to the side. It cannot go in the denominator. And that is dividing complex numbers, dividing with complex numbers. Hope it helps.